All right, here's another limiting reagent question that involves some solutions. Aluminum is used to displace silver in a solution of silver nitrate. 0.2 grams of aluminum is added to 200 milliliters of 0.15 molar silver nitrate. What is the concentration of the silver nitrate? What is the concentration of the silver nitrate solution after the reaction? Okay, so we have a bit of a different final question here. We'll deal with that when we get there, but let's get the chemical reaction written out first. So we have aluminum, metal reacting with silver nitrate, and that's going to produce aluminum nitrate, and we'll have some silver produced. Now I have 3 nitrates on the left, so I need 3 silver nitrates on the right, which means I need 3 silvers over here, and I have a balanced chemical reaction here. Said I had 0.2 grams of this, and it's sort of implied that that's going to be the limiting reagent because it asks what the final concentration of silver nitrate is. So it presumes that some of this is going to be left over, but we'll just verify that. Moles is equal to mass divided by molar mass, so 0.2 grams divided by, I think aluminum is 27, yeah, 27 grams per mole. 0.2 divided by 27 equals 0.0074 moles, so that is a very small amount. Here I have my 200 milliliter solution. Again, converting that over to liters because my concentration definition assumes liters. I got 0.2 liters, and my concentration is 0.15, so C equals N over V. Oops, over V. Oof, what am I doing here? N over V, which is 0.15, N 0.2, and so N equals 0.15 times 0.2, 0.03. So this is much smaller. I could look at my mole ratio, dividing out by 3 here because I have 3 of those for every one of those, and say that this is 0.01, and I would still see that this is still smaller. So as expected, this is my limiting reagent. Now, what the question asks is how much silver nitrate is left in the solution after the reaction. So what I'm going to do is I'm going to use my 0.0074. So this is my initial amount of silver nitrate. I'm going to use this initial amount of aluminum to figure out how much of the silver nitrate will be reacted away during this reaction. So this isn't a 1 to 3 ratio. So my moles of aluminum in comparison to my moles of AgNO3, and this will be that react, is in a 3 to 1 ratio. So I'm going to bring my moles of AgNO3. Again, this is that's going to react away. Up here, I'm going to bring the 3 up here, and I get 3 times 0.0074. Gets me 0.0222 moles of silver nitrate that participate in the reaction or that are used up in the reaction. So if I want to know how much I have left over, my final, I can take how much I had in my initial and subtract away what I lost in the reaction. So in the initial situation, I had 0.03, and I subtracted away 0.0222, and that would leave me with 0.1278 moles left over. Now this amount of aluminum reacted with this amount of silver nitrate, and these are the particles that are final or are remaining in the solution. So they did not react away. So the question asks, what is the concentration of silver nitrate remaining in solution after the reaction? So concentration is equal to moles over volume. This is for silver nitrate. I know I'm doing it underneath aluminum, but I just don't have any more space. So this is for the silver nitrate. How much silver nitrate is left? 0.0078 moles divided by my volume. The volume won't significantly change. When we add that tiny little piece of aluminum, the overall volume of the solution remains basically the same. So the volume is still 0.2 liters. And so my final concentration would be 0.039 molarity. So I had some silver nitrate and aluminum. The aluminum ran out first. I figured out how much aluminum there was and how much silver nitrate it would have used up when it ran out. And that's what this is. And then I can put that back in the form of a concentration. So this is the concentration of silver nitrate after the reaction.